We've seen a downsampling, and now it's time to take a look at upsampling. That this is still what's missing in our system. So upsampling is the opposite operation of downsampling, and it's the case where we would like to increase our sampling rate. Yeah? So what we want to do is we want to upsampling by first inserting n-1 zeros after each sample, and then we have some interpolation filter for it. Yeah? It can be a high pass or a band pass or a low pass, so it depends the frequencies we want to fish out, yeah, from the downsampled version. So what we do is we take the signal at the lower sampling rate, so this was the y of m, yeah, the index m is indicating the lower sampling rate, and then the signal at the higher sampling rate with zeros in it was the x of t superscript t of n, so index n indicating the higher sampling rate. So we can see that this is the reverse operation of the final step of removing the zeros for the downsampling. So we can take our result for downsampling. So we had this thing here, and we can see that it becomes we're not just coming from y of m going to the now upsampled signal x of t of n. So for instance, if we had the frequency pi before upsampling, then it becomes pi divided by 2 for the upsampled signal, in case we have a upsampling factor of n equals to 2. So in this way we now get an extended frequency range. So since now we have again the signal including the zeros, we again have this periodic spectrum as before, and as we progress through the same steps backwards now. So we can also see that the result of upsampling is periodic in frequency, because the signal was 2 pi periodic before upsampling anyway, and after upsampling the frequency scale replaces 2 pi times capital N by 2 pi.